Welcome back our engineering lecture series YouTube live session. Today I will explain. So last class continuation, today I will explain next topics. Already I explained in the last session exact differential equations, equations reducible to exact, how to find out the integrating factor, how to solve non-exact differential equations. Today I will explain linear differential equation, equations reducible to linear, Bernoulli's equation, Newton's law of cooling, law of natural growth and decay. Last topic is orthogonal trajectories. Today I will explain these topics. First, what is a linear differential equation? So here linear differential equation is totally depending on the dependent variable only. Here how to identify the dependent variable, then it is very easy to solve the linear differential equation. What is a linear differential equation? A differential equation is said to be linear if dependent variable and its differential coefficients occurs in the first degree, and that dependent variable differential coefficients not multiplied together. So such type of differential equation is called linear. Simply how to say that, how to define the linear differential equation? In a differential equation, if the dependent variable appears with power 1, such type of differential equation is called the linear differential equation. Suppose if we take x and y are the two variables, and the linear differential equation in y, the standard form of the linear differential equation in y is, so that is dy by dx plus p of x into y is equal to q of x. Observe clearly here y appears with degree 1. So therefore we say that it is called a linear differential equation in y. So after identifying the linear differential equation, next how to solve the linear differential equation? Before going to write the general solution, first we have to find the integrating factor. So what is the integrating factor? See here, integrating factor is e to the power integral p of x into dx. From the given differential equation, identify p of x, and using this formula find the integrating factor. After this integrating factor, write the general solution. What is the general solution? Dependent variable into integrating factor. Dependent, here in this differential equation y is the dependent variable, so dependent variable into integrating factor is equal to q of x. That means RHS of a given differential equation, q of x into integrating factor into dx plus c. So this is the general solution formula, but before going to write the general solution, we have to find the integrating factor. What is the integrating factor? Here e power integral p of x into dx. So here how to solve a linear differential equation? Just follow the 3 steps. First, identify the dependent variable. After identifying the dependent variable, write its standard form. If it is linear in y, standard form of a linear differential equation in y is dy by dx plus p of x into y is equal to q of x. After writing the standard form of a linear differential equation, next second step is find the integrating factor. So what is the integrating factor formula? E power integration of p of x into dx. After completion of integrating factor, at last write the general solution using the formula y into integrating factor is equal to integration of q of x into integrating factor into dx plus c. Why I am writing here y? Y is the dependent variable. Dependent variable into product of dependent variable into integrating factor is equal to integration of product of RHS into integrating factor into dx plus c. Just if you follow these 3 steps, then it is very easy to solve the linear differential equation. And how to write the linear differential equation in x? Similarly, the standard form of a linear differential equation in x is dx by dy plus p of y into x is equal to q of y. Observe clearly here the variable x appears with power 1. So that's why we say that it is called a linear differential equation in x. So after identifying the nature, next what is our next step? Find the integrating factor. What is the integrating factor of a linear differential equation in x is integrating factor is equal to e to the power integral p of y into dy. So this is the integrating factor. What is the third step after general solution? General solution is dependent, product of dependent variable into integrating factor. In this equation, what is the dependent variable? X. X into integrating factor is equal to right side. RHS is integration of product of RHS into integrating factor. What is the RHS here? Q of y. Q of y into integrating factor into dy plus c. So this is the general solution formula. Using this formula, write its general solution. So this is the general solution. X into integrating factor is equal to integration of q of y into integrating factor into dy plus c, where what is the integrating factor formula? E power integral p of y into dy, where p of y and q of y are the functions of y. So this is the definition of linear differential equation. Equations reducible to linear form. First of all, before going to discuss this one, equations reducible to linear, what is the linear differential equation? Here linear, suppose if we take linear differential equation in y, so what is the standard form? Dy by dx plus p of x into y is equal to q of x. Observe clearly here y appears with power 1 and dy by dx coefficient is 1. Then only we say that is a linear differential equation in y. Next, what are the equations which are reducible to linear differential equation? What is the standard form of the differential equation? So, an equation of the form f dash of y into dy by dx plus p into f of y is equal to q, where p and q are either functions of x or constant. So here observe clearly dy by dx has a coefficient f dash of y, but y appears. So here and f dash of y and p coefficient is f of y is equal to q. But what is a linear in y? That is dy by dx plus p of x into y is equal to q of x. If the given differential equation is in that form, directly write the general solution using the previous procedure. But when the given differential equation is in this form, so here p coefficient is f of y and dy by dx coefficient is f dash of y. In this case, reduce this differential equation into linear form. So how to reduce this equation into linear form? Substitute this f of y is equal to, here we have a difference. If we compare these two, here p coefficient is y with power 1. So that's why change that function by taking the substitution f of y is equal to u. If we take f of y is equal to u, so then what is its differentiation? Differentiation of f of y is f dash of y into, again differentiation of function is f dash of y, again differentiation of y is dy by dx is equal to du by dx. So if we substitute this one here, so that equation is reduced to the form, du by dx plus pu is equal to q. So here which variable? Again identify the dependent variable. Which variable appears with power 1? So observe clearly here u appears with power 1. So therefore we say that which is called a linear differential equation in u, and we know that how to find the general solution of a linear differential equation, and using that procedure write the general solution of this new differential equation. If we take equation 2 and if it is 1, first write the general solution of equation 2 using the linear procedure. But how to write the general solution of given differential equation? The general solution of given differential equation is obtained by substituting again. So by substituting u is equal to f of y in the general solution of equation 2. That last equation is the required general solution of given equation. This is the procedure to reduce equations into linear form. And Bernoulli's equation. All these three forms are related, so that's why. What is the Bernoulli's equation? An equation of the form dy by dx plus py is equal to q into y to the power n. Again compare the given differential equation with linear in y. What is the standard form of a linear differential equation? Dy by dx plus p of x into y is equal to q of x. Again, if you observe clearly, see here, dy by dx coefficient is 1, there is no problem, and py, there is also no problem since y appears with power 1. But what is the RHS? Where q is the function of x only, but what is its coefficient? Power of y. Power of y, that is y power n. So in this case also, how to reduce? Here also reduce this Bernoulli's equation into linear equation. So how to reduce? By dividing this entire equation with y power n. That means make RHS as a free from y power n. When it is free from y power n, by dividing with y power n and reduce that equation into linear form. And what are the previous questions? Before going to discuss the previous questions, first, what is a linear differential equation in y? Dy by dx plus p of x into y is equal to q of x. Linear differential equation in x is dx by dy plus p of y into x is equal to q of y. So these two are the linear differential equations. First one is linear differential equation in y and second one is linear differential equation in x. Why first one is y? Here y appears with power 1. So that's why we say that it is called a linear in y. And second one is x appears with 1, with power 1. So therefore it is called a linear in x. These two are the linear differential equations. And equation, suppose if the given equation is of the form f dash of y into dy by dx plus p of x into or p into f of y is equal to q of x. So here y not appear, but their functions, functions of y and derivative of function of y appears. So in this case, reduce this equation into linear form by taking the substitution f of y is equal to u or any another variable. F of y is equal to u. And next, this is the equations reducible to linear form. What is the Bernoulli's? A differential equation of the form dy by dx plus p of x into y is equal to q of x into, there exists another term, power of y, y power n. Such type of differential equation is called Bernoulli's equation. So any equation, that means equations, these two equations, if you know how to reduce these two equations into linear differential equation form, then it is very easy to solve the differential. 1 plus x square into dy by dx plus 2xy is equal to 4x square. Here given one condition, y of 0 is equal to 0. So if you know, so here they simply given that solve the differential equation. If a student know that how to solve the differential equation, what is the nature of the differential equation? So first identify the nature of the differential equation. What is the procedure to solve this type of differential equation? First to check the condition for exact. If it is exact, write its general solution. Again, if it is not an exact, better to go for linear equations reducible to linear or Bernoulli's equation. Then only apply the equations reducible to exact. These three methods are very easy to solve the differential equation when given differential equation is not an exact and if you know nature of the given differential equation. Yes, coming to the first equation, see here, this is dy by dx plus y is equal to x cube into y power 6. Here RHS. In linear differential equation, RHS is function of x only. In equations reducible to linear form also, RHS is function of x only. But here, function of x cube product is y power 6. That means there exists a power of y. So therefore, write this differential equation into Bernoulli's standard form. Bernoulli's standard form. That is the procedure to identifying the nature of the given differential equation. Coming to the second question, dy by dx plus y by x is equal to sine 2x. Observe clearly which variable appears with power 1. If you know that condition, then it is very easy to solve the differential equation. Here y appears with degree 1, but here x and there exists its function also sine 2x. So here only y appears with degree 1. So therefore this is the linear differential equation in y. That is a linear differential equation in y. After identifying the nature of the differential equation, write its standard form. That is a very, very important. First, when we know the standard form of a given differential equation, then it is very easy to find its integrating factor and write the general solution. Coming to the third equation, dy by dx plus y into tan x is equal to y cube into secant x. Here also in RHS there exists a power of y. So this is also a Bernoulli's differential equation. These are the maximum times repeated questions. Okay. So this is also a Bernoulli's equation. Next, coming to the fourth question, 1 plus x square into dy by dx plus 2xy is equal to 4x square. Leave about this condition. So first, identify the nature of the differential equation. Which variable appears with power 1? That is a very, very important. Now observe clearly here y only. So y appears power 1. So therefore is a linear differential equation in y. But what is the standard form of linear differential equation in y? That is dy by dx plus p of x into y is equal to q of x. But here in the standard form dy by dx coefficient is 1. But here what is the dy by dx coefficient is 1 plus x square. To reduce this equation into standard form, first divide that entire differential equation with 1 plus x square. Then that equation becomes linear in y. Yes. Next questions, solve x plus 2y cube. Suppose if the question is in this form, how to identify the nature? Here also identify the dependent variable. So what is a dependent variable? Which variable appears with power 1? So observe clearly this equation. Here x appears with power 1. So that means reduce the differential equation into linear in x form. What is the standard form of linear in x? Standard form of linear in x is dx by dy plus p of y into x is equal to q of y. If you know how to identify the dependent variable, then we can easily write its standard form. So next, find the integrating factor. This is the short answer question. Find the integrating factor of the differential equation. Dy by dx minus y into sine 2x is equal to cot x. So what is the nature of the differential equation? Identify the dependent variable. So now here y appears with power 1. So therefore is a linear in y. When the given differential equation is linear in y, then we know that what is the integrating factor. Next, coming to the next question, dy by dx plus y by x is equal to y square into x sin x. Here dy by dx coefficient is 1, but in RHS we have powers of y. So therefore this differential equation is Bernoulli's equation. Next, coming to the last one. So dy by dx equal to e power x minus y into e power x minus e power y. So first multiply this expression with e power x minus y and write that equation as a equations into. So here only x, only y does not exist. Here function of x, function of y exist. So that means that is the equations reducible to linear form. So this is the procedure to identify the nature of the given differential equation. When we know the nature, then it is very easy to solve the given differential equation. First question, solve dy by dx plus y is equal to x cube into y to the power 6. What is this is of the form? The given differential equation is of the form. If we consider is equation 1. So equation 1 is of the form. First write the standard form. Is of the form. Yes, what is the standard form? Is not a linear. Clearly we say that is not a linear because here in RHS there exists a power of y and is not a equations reducible to linear form because there are no functions of y. Okay, so therefore is of the form. What is the standard form? dy by dx plus p of x into y is equal to q of x into y to the power n. That means the given differential equation is a Bernoulli's equation. How to solve the Bernoulli's equation? First, change RHS is free from y, power of y. So that means to change RHS is free from y, dividing entire equation with y power 6. If we dividing entire equation with y power 6, we can write y power 6 into y power minus. If we dividing with y power 6, 1 by y power 6 is y power minus 6. Y power minus 6 into dy by dx plus y by y power minus 6, that is equal to y to the power minus 5 is equal to x cube. Now RHS is free from y, but still it is not a linear differential equation. Here we have dy by dx coefficient is y power 6. So how to change this differential equation into linear form? So here also change the dependent variable y power minus 5. So that is change y power minus 5 is equal to u. So if we take the substitution y power minus 5 is equal to u, differentiate it. Here we have to find this entire term. So that means differentiate this one with respect to x. Differentiation of y power minus 5 is minus 5 into y to the power minus 6 into dy by dx is equal to du by dx. But we need only y power minus 6 into dy by dx. So to find that value, dividing with minus 5. So how to write this one? Y power minus 6 into dy by dx is equal to minus 1 by 5 into du by dx. This is the term we require. Okay. Suppose if we consider is equation number 2 and substitute this value. Y power minus 6 into dy by dx in equation 2. That means substitute equation 3 in equation 2. So substitute equation 3 in equation 2. Now equation 2 can be written as, what is a y power minus 6 into dy by dx is equal to minus 1 by 5 into du by dx plus, what is a y power 5? This is our substitution term. So what is a y power 5? That is equal to u is equal to x cube. Still it is not in the linear form. In a linear form, dy by, that means differential coefficient is 1 only. But here what is the coefficient is minus 1 by 5. So how to write that one? That is equal to, so that implies du by dx. By cross multiplication we can write that is equal to minus 5u is equal to minus 5 into x cube. Is equation number 4. Observe clearly, what is the equation? Du by dx minus 5u is equal to minus 5x cube. Again identify the nature of the differential equation. Now here u, the variable u appears with the power 1. So therefore is a linear differential equation. This equation 4 is a linear differential equation in which variable? U. When it is a linear differential equation in u, write its standard form. What is the standard form? So in u is of the form du by dx plus p of x into u is equal to q of x. This is the standard form of a linear differential equation in u. So again identify p of x and q of x. Where? P of x. What is the p of x? P of x is equal to minus u. If you compare these two equations where p of x is equal to minus 5, where p and q are either functions of x or constants. So here P of x is equal to minus 5 and Q of x is equal to minus 5x cube. So after identifying P and Q, to write the general solution of a linear differential equation, we need integrating factor. What is the integrating factor? Now, integrating factor is, what is the formula for integrating factor? E to the power integral P of x into dx. We know that P of x from the above condition. So, which is equal to e to the power integral. What is the P of x? P of x is equal to minus 5 into dx. So, which is equal to e power minus 5 into, what is the integration of dx? X. So, that is e to the power minus 5x. What is the integrating factor of a new differential equation? 4 is e to the power minus 5x. After finding the integrating factor, how to write the general solution? So, the general solution is, so what is the integrating factor here? Integrating factor is equal to e to the power minus 5x. Now, general solution of, first write the general solution of new differential equation, new linear differential equation. So, that means equation 4. So, general solution of equation 4 is, what is the formula? Equation 4 is a linear differential equation in U. So, that's why U is the dependent variable, product of the dependent variable and integrating factor is equal to integration of RHS. So, what is the RHS? Q of x into integrating factor into dx plus c. Now, substitute the required terms. So, now that implies u into, what is the integrating factor? E to the power minus 5x is equal to, what is the Q of x? Q of x is equal to minus 5x cube into, what is the integrating factor? E to the power minus 5x into dx plus c. Now, find the integration of this one. Here, apply the integrating by parts. So, this is the u, this is the u and this is the v. We have one general formula. What is the general formula? Integration of uv is equal to u into v1 minus u dash into v2 plus u double dash into v3 minus u triple dash into v4 plus on, where v1 indicates integration of v into dv, u dash indicates differentiation of u. If you apply that formula, then it is very easy to find the integral value. So, now that implies u into e power minus 5x is equal to, here minus 5 is the constant. So, just apply that formula. U, what is the u? X cube into v1. v1 is nothing but integration of v. What is the integration of e power minus 5x? E to the power minus 5x by minus 5. Next, minus u dash. What is the u dash? Differentiation of x cube. Differentiation of x cube is 3x square. 3x square into v2. v2 is nothing but integration of v1 or 2 times integration of v. Already we know that v1. So, if you integrate this v1, we get v2. So, what is the integration of e power minus 5x by minus 5? E power minus 5x by minus 5 whole square. Next, plus u double dash. Differentiation of 3x square. This is u, this is u dash. So, what is the u double dash? Differentiation of 3x square. Differentiation of 3x square is nothing but 6x into v3, that means integration of v2. What is the integration of this one? That is equal to e to the power minus 5x by minus 5 whole cube. Next, minus fourth derivative of 6x, sorry, u dash, u double, third derivative of 6x means triple dash of u triple dash. Differentiation of 6x is nothing but 6. Differentiation of x is 1 and again integration. So, what is a v4? So, integration of this one is e to the power minus 5x by minus 5 whole power 4. If you continue the next one, again differentiation of 6. What is the differentiation of constant? 0. So, that's why no need to take the other terms. No need to take next terms because all the derivatives of u are 0. Next, simplify this one here and plus c. What is that? Constant is plus c. So here what are the common terms? That implies u into e power minus 5x is equal to, if we take e to the power minus 5 into e power minus 5x by minus 5 into, only if you take this term is outside, so that is equal to, if we take minus 5 is outside, what is the first one? X cube. Next, here minus 5 whole square, so that is plus, but here we take minus is common, so that is minus into minus plus 3x square by 5. Sorry. Yes, just to take only e power minus 5x by 5. So here we have minus and minus x cube. Next here if we take minus 1, 5 is outside. So minus 1 whole square. So that is equal to plus 5 square. 1 5 is outside, that is minus 3x square by 5. Next, coming to the second equation. So that is coming to this term. So if we take minus 5 is plus 5 is outside. So that is equal to minus, this is minus 6x by 5 square. 6x by 5 square. Next one is if we take minus 5 is, only 5 is outside. So that is minus 6 by 5 cube plus c. Okay, so that implies here 5 get cancelled. So that implies u. What is the u? Here in our previous substitution, u is equal to y to the power minus 6. Y power minus 6, and if you cancel and if you divide entire equation with e power minus 5x, that is equal to minus. So minus into minus, again multiply this minus with inside. So that is equal to x cube minus plus 3 by 5 into x square plus 6 by 25 into x minus plus 6 by 125 plus c, which is the required solution of a general solution of a given differential equation. What is a given differential equation? Is a Bernoulli's equation. This is the long answer question. This is the procedure to solve the given differential equation. Next, solve. dy by dx plus y by x is equal to sin 2x. So before going to solve the given differential equation, when you know the idea about the linear Bernoulli's, then it is very easy. So first, identify the nature. So here, which variable appears with power 1? Observe that one. So here, y appears with power 1. So therefore, it is a linear differential equation in y. So equation 1 is of the form. So first, equation 1 is of the form. Yes, what is the standard form? Is a linear differential equation in y. What is the standard form of a linear differential equation in y? That is dy by dx plus p of x into y is equal to q of x. First, compare the given equation with this standard form and write the required terms. Where? What is a p of x? So if we compare these two, what is a p of x? P of x is equal to 1 by x. That is y coefficient 1 by x. And what is a q of x? Q of x is equal to sin 2x. After identifying p and q, next to solve a linear differential equation, I first identify the nature. Here nature is a linear differential equation. When it is linear, find the integrating factor. What is the integrating factor here? So here integrating factor is equal to e to the power integral p of x into dx, which is equal to e power integral. What is the p of x? 1 by x. 1 by x into dx is equal to e to the power. What is the integration of 1 by x? Log x. What is the e power log x? That is equal to x only. So what is our integrating factor? Integrating factor is x. After completion of integrating factor, next what is the last step? Write the general solution. How to write the general solution? Using the formula. So therefore, general solution of equation 1 is formula. So what is the formula? Dependent variable into integrating factor. Here what is the dependent variable? Y. So first write the formula. Y into integrating factor is equal to integration of product of RHS. What is RHS? Q of x into integrating factor into dx plus c. Now substitute the values. That implies y into, what is our integrating factor? X. X is equal to integration of, what is the q of x? Q of x is equal to sine 2x into integrating factor is x into dx plus c. Here also apply the integrating by parts formula. So let us consider x is u and sine 2x is v. So apply the formula. So that implies xy is equal to, so what is the integrating by parts formula? First u, what is again? Integration of uv is equal to u into v1 minus u dash into v2 plus u double dash into v3 minus so on. So that is u. What is the u? X. v1. What is the integration of sine 2x? Now here write integration of sine 2x. Integration of sine 2x is minus cos 2x by 2 minus u dash. Differentiation of x. What is the differentiation of x? 1. And v2. v2 is nothing but integration of v1. Already we know that v1. This is the v1. What is the integration of minus cos 2x? That is equal to minus sine 2x by 2. Already we have 2. So that is equal to 4. Next plus differentiation of 1. What is the differentiation of 1? 0. So no need to write the next two terms and constant is c. Simplify this one. That implies xy is equal to minus x into cos 2x by 2 minus into minus plus sine 2x by 4 plus c, which is the required general solution of a given differential equation. In examination also present your solution in this form. Don't write equal in jumbling form. So write in uniformly. Okay. So this is the solution of second one. Next question. Solve dy by dx plus y into tan x is equal to y cube into secant x. So first identify the nature. So which equation already discussed? This one. What is the? This is here in RHS there exists a power of y. So therefore is a Bernoulli's equation. So if we consider the given equation is 1, so equation 1 is in Bernoulli's form. So what is the standard form of Bernoulli's equation? Equation 1 is of the form. What is the standard form of a Bernoulli's differential equation? Dy by dx plus p of x into y is equal to q of x into y to the power n. So what is our procedure? First change RHS free from y. So that means here what is the, in RHS what is the y power? Y cube. So first to divide entire equation with y cube. If we divide entire equation with y cube, so how to write that equation? Equation 1 can be written as after dividing with y cube. So that is equal to y power minus 3 into dy by dx plus y by y cube. Y by y cube is nothing but y to the power minus 2 into tan x is equal to secant x. Now RHS is free from y but is not a linear form. So how to reduce this equation into linear form? By taking the substitution. This is p of x into y, but here what is the y power? Minus 2. So that's why take the substitution is let y power minus 2 is equal to another variable u. That means change the dependent variable. Y power minus 2 is equal to u. If we take this substitution and differentiate this one with respect to x. What is the differentiation of y power minus 2? Minus 2 into y to the power minus 2 minus 1. minus 3 into dy by dx is equal to du by dx. But we need only y power minus 3 into dy by dx. Let us take is equation number 2 and equation 2. In equation 2, we need only y power minus 3 into dy by dx. So, simplify for that one. Y power minus 3 into dy by dx is equal to, if we dividing with minus 2, minus 1 by 2 into du by dx. Okay. If we consider is equation number 3, now substitute 3 in equation 2. So, if we substitute 3 in equation 2, substitute 3 in equation 2. So, equation 2 becomes, what is the y power minus 3 into dy by dx? Minus 1 by 2 into du by dx plus, what is the y power minus 2? U, and its coefficient is tan x. Write this one as tan x into u is equal to secant x. Still it is not in linear form. Here du by dx coefficient is minus 1 by 2. So, rewrite that equation as, so how to write that equation? That equation as du by dx minus 2 into tan x into u is equal to minus 2 into secant x is a new differential equation, and this new differential equation is equation number 4, and this new, in a new differential equation, again identify the dependent variable. What is the dependent variable? U, since u appears with power 1. So, therefore, is a linear. So, equation 4 is a linear differential equation in u. What is the standard form? So, after identifying the nature, first write the differential equation into standard form. What is the standard form? And is of the form. And is of the form. What is the standard form of a linear differential equation? Du by dx plus p of x into u is equal to q of x is linear in u. So, that is why write standard form also in terms of u. Du by dx plus p of x into u is equal to q of x. Again compare equation 4 with this standard form where, what is the p of x? Where p of x is equal to minus 2 into tan x and q of x. Q of x is equal to minus 2 into secant x. Next, after identifying p of x, what is our next step? Finding the integrating factor. What is the integrating factor here? Now find the integrating factor of equation 4, not given equation. So, what is the integrating factor? Integrating factor is equal to e to the power integral p of x into dx, which is equal to e to the power integral. What is our p of x? Minus 2 into tan x into dx. So, which is equal to e to the power minus 2 into, what is the integration of tan x? Integration of tan x is minus log of secant x. So, that is our choice. So, integration of tan x is equal to minus log of cos x. Again, minus into minus plus. So, how to write this one? Which is equal to e to the power log of cos square x or cos x whole square. What is the e power log of cos square x? That is equal to only cos square x. That is an integrating factor. Now, how to write the general solution of new differential equation, new linear differential equation 4? So, here integrating factor is cos square x. So, what is the general solution? Therefore, general solution of equation 4. Here equation 4 is a new differential equation after substituting the given dependent variable into another variable. So, general solution of equation 4 is, so equation 4 is a linear in u. So, that is why u into integrating factor is equal to integration of q of x into integrating factor into dx plus c. Next, substitute the integrating factor here, u into, what is the integrating factor? Cos square x is equal to integration of, what is the q of x? q of x is equal to here minus 2 into secant x. So that is minus 2 into secant x, and what is the integrating factor? Cos square x into dx plus c. Secant x can be written as 1 by cos x. If we simplify RHS, u into cos square x is equal to minus 2 into here 1 secant 1 cos x get cancelled, that is equal to only cos x into dx plus c. What is the integration of cos x? Again, u into cos square x is equal to minus 2 into integration of cos x is sin x. Sin x plus c is the general solution of equation 4. But general solution of equation 1 is obtained by substituting u is equal to, yes, what is our substitution? That is u is equal to y power minus 2. So by substituting u is equal to y to the power minus 2. So therefore we can write this equation as, so how to write that equation is u is equal to y to the power minus 2. So y power minus 2 into cos square x is equal to minus 2 into sin x plus c. Again we can also write that is cos square x by y square is equal to minus 2 into sin x plus c, which is the required general solution of given Bernoulli's differential equation. So this is the solution of a given differential equation. My dear students, please try to solve the next remaining questions and post your answer. That means integrating factor or general solution. Please post your answer in chat box. Next question. Solve 1 plus x square into dy by dx plus 2xy is equal to 4x square. First find the general solution. We will see about next about that condition. Okay, first identify the nature. So to identify the nature, which variable? So identify that which variable appears with power 1. So here which variable appears with power 1? Y. So is a linear in y, but the given differential equation is not in the standard form. What is the standard form of the given differential equation, linear differential equation in y? Dy by dx. What is the standard form? Standard form is dy by dx plus p of x into y is equal to q of x. This is the standard form, but the given differential equation is not in the standard form because dy by dx has a coefficient 1 plus x square. So how to write this differential equation into the standard form? By dividing with 1 plus x square. So if we are dividing with 1 plus x square, if we consider equation 1, so equation 1 can be written as, so how to write? Can also be written as dy by dx. If we are dividing entire equation with 1 by 1 plus x square, so that is 2x by 1 plus x square. Sorry, if we are dividing with 1 plus x square, we get 2x by 1 plus x square into y is equal to 4x square by 1 plus x square. This is the in the standard form of linear in y. So consider is equation 2. So equation 2 is of the form. Equation 2 is of the form. What is the standard form? Standard form is dy by dx plus p of x into y is equal to q of x. Just to follow 3 steps to solve the linear differential equation. What is our first step? First, write the standard form of a given differential equation. Second step is finding the integrating factor. Last step is write the general solution. If you follow these 3 steps, then we get the solution in easy way. Okay, so if you compare equation 2 with the standard form, where what is the p of x? P of x is equal to 2x by 1 plus x square. And what is the q of x? Q of x is equal to 4x square by 1 plus x square. What is our second step? Finding the integrating factor. So what is the integrating factor? Now integrating factor. Now, what is integrating factor? Integrating factor is equal to e to the power integral p of x into dx. From the standard form, we know that what is a p of x? What is a p of x? 2x by 1 plus x square is equal to e to the power integral. What is a p of x? 2x by 1 plus x square into dx. Now, how to integrate this one? So, again, we know that in intermediate substitution method or direct formula. So, this is of the form. So, what is that form? Integration of, when the integration is of the form, integration of f dash of x by f of x into dx. When the integration is in this form, integration of f dash of x by f of x, what is its integration? That is equal to log of f of x. Now, see here, what is f of x? 1 x square. What is the differentiation of 1 plus x square? 2x. So, which is in the form of f dash of x by f of x. What is the integration of f dash of x by f of x? That is equal to e to the power. Integration of f dash of x by f of x equal to log of f of x. What is f of x here? 1 plus x square. Again, e to the power of log of 1 plus x square can be written as that is equal to 1 plus x square. Now, what is our integrating factor? 1 plus x square. So, after completion of integrating factor, next write its general solution. Just to follow 3 steps. Second step completed, and what is the third step? So, third step is general solution of equation 2 or equation 1 is. So, what is the general solution? Dependent variable. What is the dependent variable? Y into integrating factor. First write the formula, then only substitute the values. Y into integrating factor, integral q of x into integrating factor into dx plus c. Now substitute the terms. What is our integrating factor? 1 plus x square. See here. Integrating factor is equal to 1 plus x square. So, y into 1 plus x square is equal to integration of, what is the q of x? Q of x is equal to 4x square by 1 plus x square. So, that is 4x square by 1 plus x square into, what is integrating factor? 1 plus x square into dx plus c. Observe clearly, these two terms are cancelled. So, how to write this solution? Y into 1 plus x square is equal to 4 into integration of x square into dx plus c. What is integration of x square? X cube by 3. So, y into 1 plus x square is equal to 4 into x cube by 3 plus c. So, which is the required general solution of a given differential equation. So, this is the procedure and this is the general solution. Here given one more condition. What is that condition? Y of 0 equal to 0. What is the purpose of that condition? That means find the particular solution. What is the particular solution? Particular solution is obtained from the general solution by substituting values for arbitrary constant. So, that means here to find the particular solution, we have to find this arbitrary constant value c using the given condition. So, let us consider is equation number 3. So, to find the particular solution, first write the given condition. So, what is the given condition? Y of 0 equal to 0. Y of 0 equal to 0 is nothing but what is the meaning of this one? So, that is y value is 0 when x is equal to 0. Y value is 0 when x is equal to 0. That is the meaning of the given initial condition. That condition is called the initial condition. So, using the initial condition, find the arbitrary constant. So, here put y equal to 0 and x equal to 0 in equation 3. So, put y equal to 0 and x equal to 0 in equation 3. So, if you put y equal to 0 and x equal to 0 in equation 3, y equal to 0. So, that means LHS is 0. We get Equation 3. From equation 3, LHS is 0. And what is RHS? 4 into 0. That is also 0 plus C. So from this, what is the arbitrary constant value? C is equal to 0. Next, this is the general solution. Particular solution. Particular solution is obtained by substituting the arbitrary constant values in the general solution. So put C is equal to 0 in equation 3. So if we substitute C equal to 0 in equation 3, we get a particular solution. That solution is called the particular solution. We get particular solution. So what is the particular solution? So therefore, y into 1 plus x square is equal to 4 into x cube by 3. What is the C value? 0. So which is the particular solution of a given differential equation? So meaning of this condition is find the particular solution of the given differential equation. Particular solution is obtained from the general solution by substituting particular values to arbitrary constant. How to substitute particular values to arbitrary constant? Using the given condition, find the C value. At last, substitute C in general solution, then that solution is called a particular solution. This is the procedure to find the particular solution. Next, solve. X plus 2y cube into dy by dx is equal to y. Here, identifying the nature of the given differential equation is important. So, observe clearly and identify which variable, dependent variable. Observe that which variable appears with degree 1, with power 1. So, now here y and y cube. Y is not appear with power 1. So, here only x appears with 1. That means write the given differential equation as a linear differential equation in x. Here x is the dependent variable. That is a very, very important key point. That means what is the key point? Identifying the dependent variable in a given differential equation. So now what is the linear differential equation in x? If you know the idea about the linear in x, then it is very easy to convert given differential equation into linear in x. So here x appears with power 1. That means is a linear differential equation in x, but which is not in the standard form. But what is the standard form of a linear differential equation in x? So that is dx by dy plus p of y into x is equal to q of y. This is the standard form of a linear differential equation in x, but the given differential equation is not in the standard form. So how to reduce this differential equation into standard form? So what is the first one? Dx by dy. So that means how to write? If we consider equation 1 can be written as, how to write? X plus 2y cube is equal to, by cross multiplication we can write that is y into dx by dy. Y into dx by dy. So again rewrite this equation as y into dx by dy, and if you take this x to right side, that is minus x is equal to 2y cube. Still this differential equation is not in the standard form. Why? Here dx by dy coefficient is y. So first, next dividing this equation with y. So that is dx by dy minus x by y is equal to 2y square. After dividing with y, we get a new differential equation. Now tell me, this equation, this new differential equation is a linear in x. When we know nature of the given differential equation, this is the procedure to convert the given differential equation into standard form. So what is the standard form? Equation 2 is of the form. Equation 2 is of the form. Yes, what is the standard form? Dx by dy plus p of y into x is equal to q of y. Compare equation 2 with this standard form. What is the p of y? Where p of y is equal to minus 1 by y. X coefficient. Here what is x coefficient is 1 by y. Next, q of y. What is the q of y? Q of y is equal to 2y square. What is our next step? Finding the integrating factor. So what is the integrating factor? Now integrating factor is, what is the integrating factor? E to the power of, is a linear in x. So what is the integrating factor? E to the power integral p of y into dy is equal to e power integral. What is our p of y? P of y is equal to minus 1 by y. That is minus 1 by y into dy, which is equal to e power minus. What is the integration of 1 by y? Integration of 1 by y is equal to log y. Again, how to write this one? Log of y to the power minus 1. Again, which is equal to y power minus 1. Y power minus 1 is 1 by y. So, finding integrating factor in this way. So, what is integrating factor is equal to 1 by y. So, after finding, how to write the general solution. So, therefore, general solution is, what is the general solution? Is linear in x. So, how to write the general solution? X into integrating factor is equal to integral q of y into integrating factor into dx plus c. This is the formula. So, now that implies x into, what is our integrating factor? Integrating factor is 1 by y. So, integrating factor is equal to 1 by y is equal to integration of, what is the q of y? Q of y is equal to 2y square. So, that is 2y square into integrating factor is 1 by y, sorry here. So, that is equal to dy, sorry for that one, into dy plus c. Again, so simplify this one, which is x by y is equal to 2 into integration of y into dy plus c. What is integration of y? X by y is equal to 2 into integration of y is y square by 2 plus c. Now cancel 2, that implies x is equal to y cube plus cy is the required general solution of a given linear differential equation. This is the procedure. Okay. Please take 5 minutes break. Welcome back. So this is the solution, general solution of a given differential equation. And my dear students, please find the solution of this one. This is only integrating factor. So what is this one? This differential equation is, already I told that what is the nature of this differential equation? Is linear in y, and find the integrating factor using the formula. Please try to solve all these questions. Next, applications of first order differential equations. We have three applications. First one is Newton's law of cooling. So what is the short answer question from this topic is? So state Newton's law of cooling. 1 or 2 or 3 marks question. So state Newton's law of cooling. That is the short answer question. How to state the Newton's law of cooling? So what is the statement? It states that rate of change of temperature of the body is directly proportional to the difference between the temperature of the body and its surrounding medium. This is the general statement. So mathematically, how to write the differential equation? So suppose let theta be the temperature of the body at the time t and theta naught be the temperature of its surrounding medium. So what is our statement? Rate of change of temperature of the body. That means d theta by dt is directly proportional to the difference between the temperature of body and its surrounding medium. So that means what is the differential equation? D theta by dt is proportional to theta minus theta naught. So now here take the proportional constant is minus k. So that means when T increases, temperature decreases. So that's why take the proportional constant is minus k. If we solve this differential equation, we get the required temperature of the body or required time. So where k is a positive constant. So previous year's questions. So what is the first question? A body originally at 80 degrees centigrade cools down to 60 degrees centigrade in 12 minutes. The temperature of air being 40 degrees centigrade. What will be the temperature of the body after 40 minutes from the original? So this is the given question, and how to write the given data in a proper way. So what is the first one? A body originally at 80 degrees centigrade. So that means initially. So how to write the given data? When initially time t is equal to 0. When t is equal to 0, what is the theta value? 80 degrees centigrade. Temperature of the body is 80 degrees centigrade. And it cools down to 60 degrees centigrade in 20 minutes. So how to write the next one? When t is equal to 20, what is the theta? Theta is equal to 60 degree centigrade. And the temperature of the air being 40 degrees centigrade. So what is the notation for temperature of the surrounding medium? Theta naught. What is the theta naught? 40 degree centigrade. What we have to find? What will be the temperature of the body after 40 minutes? When T is equal to 40, find the temperature of the body. This is our question. First write the given data in the proper order. Now apply the Newton's law of cooling. So what is the Newton's law of cooling? Newton's law of cooling states that the rate of change of temperature of the body is proportional to the difference between the temperature of the body and its surrounding medium. So first solve the differential equation, and here what is the proportional constant is minus k. So how to write? D theta by dt. See here, when t increases, theta decreases. So that's why take the proportional constant is minus k, that is equal to minus k into theta minus theta naught. First find this equation. So that is, so now here the variables are in separable form. So how to write this one? D theta by theta minus theta naught is equal to minus k into d theta. When the variables are in separable form, next to find the solution, take integration on both sides. So if we take the integration on both sides, what is the integration? Integration of d theta by theta minus theta naught is equal to minus k into integration of dt plus integral constant is c. What is integration of 1 by theta minus theta naught? Here theta naught is a constant value. So that is log of theta minus theta naught is equal to minus kt plus c. This is the required solution. But how to find out? So substitute the given values. What is the given theta naught? Theta naught is equal to 40. So put theta naught is equal to 40. If we consider is equation 1, in equation 1 we have two unknown terms, that is unknown constants. One is c and one is the proportional constant k. So first substitute theta naught is equal to 40. So that implies equation 1 becomes, from equation 1 how to write, which is equal to log of theta minus 40 is equal to minus kt plus c. So is equation number 2. Now find these two values, c and k values. First to find the c value, then find k value. How to find out the c value? Using the given conditions. First initial conditions. So what are the initial conditions? When T is equal to 0, what is the temperature of the body? Theta is equal to 80 degrees centigrade. So that is substitute. When T is equal to 0, theta is equal to 80 degree centigrade. So therefore equation 2 becomes, what is equation 2? Log of theta naught, theta minus, yes, log of theta minus 40. But what is the theta value here? Theta is equal to 80. 80 minus 40, but T is equal to 0. That is minus k into 0 plus c. So from this equation, what is the c value? C is equal to log of 80 minus 40 is log 40. C is equal to log 40. Here apply the successive substitution procedure. Immediately substitute C is equal to log 40 in equation 2. So put C is equal to log 40 in equation 2. So what is the equation 2? Equation 2 is log of theta minus 40 is equal to minus kt plus, what is the C? C is equal to log 40. So from this two logarithm, if we take this log 40 left side, that is log a minus log b. So from these two logarithmic terms, how to write? So that implies we can write that is log of theta minus 40 by 40 is equal to minus kt is equation number 3. Is obtained after substituting C. Next, find the k value. So how to find out the k value? Using the next conditions, given conditions. What are the given conditions? When T is equal to 20, theta is equal to 60 degrees centigrade. So that means when T is equal to 20, theta is equal to 60 degrees centigrade. So therefore equation 3 becomes, how to write equation 3? Log of, what is the theta? 60. 60 minus 40. 60 minus 40 is equal to 20 by 40 is equal to minus k into, what is the T? 20. So from this equation, just write the minus k value or k value, that is your choice. Minus k is equal to log of. So here we have 20, so that is equal to so minus k is equal to 1 by 20 into, so that is equal to log of 20 by 40 is equal to 1 by 2. Log of 1 by 2. After finding the k value, substitute again in equation 3. So that means substitute minus k is equal to 1 by 20 into log of 1 by 2 in equation 3. So now how to write equation 3? Equation 3 can be written as, so log of theta minus 40 by 40 is equal to, yes, what is the minus k value? 1 by 20 into log of 1 by 2 into t. Next, what we have to find? So here we have to find what will be the temperature of the body after 40 minutes. That means when T is equal to 40, suppose if we consider is equation number 4, when T is equal to 40. So when T is equal to 40, find the temperature of the body. So when T is equal to 40, equation 4 can be written as, how to write? So that is log of theta minus 40 by 40 is equal to 1 by 20 into log of 1 by 2 into 40. Now here 21s are 22s. So that implies, again rewrite this equation, log of theta minus 40 by 40 is equal to, this can be written as 2 into log of 1 by 2. But 2 into log of 1 by 2, a log b is equal to log of b power a. So how to write? Log of theta minus 40 by 40 is equal to log of 1 by 2 whole square, that is equal to 1 by 4. Now cancel logarithm on both sides. If we cancel logarithm on both sides, so then we get theta minus 40 by 40. So continuation of last step. Theta minus 40 by 40 is equal to 1 by 4. So how to write? This is theta minus 40 is equal to 40 by 4. So that is equal to 10. So that is theta is equal to 10 plus 40, 50 degree centigrade. So the temperature of the body will be 50 degree centigrade after 40 minutes. So this is the required temperature of the body. This is the solution. First write the statement and solve it and substitute the values step by step. Find the C value and K value. At last find the required temperature of the body or required time. So this is the procedure to solve a given, to find the given temperature of a body. Next, second question. The temperature of the hot body reduces from 120 to 80 degrees centigrade in 12 minutes. Find when the temperature will be reduced to 40 degrees centigrade if the temperature of surrounding air is 30 degrees centigrade. That means here we have to find the time. Okay. So how to write the given data? So first, given data can be written as, given that initially when T is equal to 0, when T is equal to 0, what is the initial temperature is 120 degree centigrade. And after, so 120 to 80, so it reduces from 120 to 80 in 12 minutes. That means when T is equal to 12, what is the theta value is 80 degree centigrade. And what we have to find? Find the temperature will be, find when the temperature will be reduced to 40 degree centigrade. When the temperature of a body is 40 degree centigrade, that means we have to find this time. And what is the temperature of the surrounding air? Theta naught is equal to 30 degree centigrade. So here, from the Newton's law of cooling or according to the Newton's law of cooling, what is the statement? According to the Newton's law of cooling, we have d theta by dt is proportional to theta minus theta naught. So, and how to write this differential equation? D theta by dt is equal to minus k into theta minus theta naught. And after separating the variables and taking the integration, we get equation log of theta minus theta naught is equal to minus kt plus c. But given that, now substitute the given values step by step. What is the given temperature of surrounding air? 30 degrees centigrade. So put theta naught is equal to 30 degrees centigrade. So then this equation becomes log of theta minus 30 is equal to minus kt plus c. Let us take is equation number 1. Now in equation 1 we have two constants. One is integral constant, one is proportional constant. Find those two constant values one by one. So first to find out the first C value when t is equal to 0 using theta is equal to 120. When t is equal to 0, theta is equal to 120. So now how to write equation 1? Equation 1 can be written as log of theta is 120 minus, what is the theta naught? Theta naught is equal to 30. So that means log of 120 minus 30 is equal to minus k into t is equal to 0 plus c. So from this equation, c is equal to log of 120 minus 30, that is equal to log 90. So c is equal to log 90. Put, when we find the constant value, apply the successive substitution procedure. Put c is equal to log 90 in equation 1. So what is equation 1? Log of theta minus 30 is equal to minus kt plus c. What is the c? C is equal to log 90. Again, from these two, how to write? Combine those two logarithms, that is log of theta minus 30 by 90 is equal to minus kt is equation number 2. One constant value completed. So next, find out the k value. So how to find out the k value? Using the second conditions. What are the second conditions? When t is equal to 12, theta is equal to 80. When t is equal to 12, theta is equal to 80. So now how to write equation 2? Equation 2 can be written as log of, what is the theta value? 80. 80 minus 30, 50 by 90 is equal to minus k into, what is the t value? 12. Now here, using this condition, find out the minus k value. So what is the minus k value? That implies minus k is equal to, if you take 12 left side, so that is equal to 1 by 12 into log of 5 by 9. This is the minus k value. Again, what is our next step? Apply substitution procedure. Substitute minus k value in equation 2. So put or substitute minus k is equal to 1 by 12 into log of 5 by 9 in equation 2. So what is equation 2? Equation 2 becomes log of theta minus 30. Here right, we get log of theta minus 30 by 90 is equal to, what is the minus k value? Minus k is equal to 1 by 12 into log of 5 by 9 into t. So next, what we have to find? So find when the temperature will be reduced to 40 degrees centigrade. So that means here we have to find out the t value. So that means when theta is equal to 40 degrees centigrade. So when theta is equal to 40 degrees centigrade, if you consider it is equation number 3. So when theta is equal to 40, equation 3 becomes, how to write? Log of, yes, what is the theta? 40. 40 minus 30, 10. 10 by 90 is 1 by 9 is equal to 1 by 12 into log of 5 by 9 into t. So from this equation, simplify that equation for t. So how to write? That is t is equal to 12 into, by cross multiplication, 12 into log of 1 by 9 by log of 5 by 9. So if we simplify this one, we get the solution. So what is that solution? Is equal to approximately, so that value is 44.857. So is approximately 45 minutes. That is the required time t. This is the solution. Next application, law of natural growth or decay. So what is the statement? Here also, this is also a short answer question. State law of natural growth or state law of natural decay. So how to state? Suppose x of t be the amount of substance at time t then the rate of change of amount of a chemically changing substance is proportional to the amount of the substance available at that time. So this is the statement of a law of natural growth or decay. So how to write its differential equation? So what is the differential equation? That is dx by dt is proportional to the x. Here x of t is the amount of the substance. So the rate of change of the given amount of the substance is proportional to the amount available at that time. So here how to write this equation? So if we take k is the proportional constant, dx by dt is equal to kx. So what happened? When t increases and x also increases, take the proportional constant is k. When t increases, x decreases, then take the proportional constant is minus k. So those two indicates growth and decay. So how to write? Where k is a proportional constant, and if as t increases, x increases. So how to write the differential equation? Dx by dt is equal to kx. That means take the proportional constant is plus k. And if as t increases, x decreases, take the differential equation as dx by dt is equal to minus kx. That means for decay, take the proportional constant is minus k. So these two indicate. So how to write? Simple way. For growth, what is the differential equation? Dx by dt is equal to kx. And for decay, what is the differential equation? Dx by dt is equal to minus kx. So these two are the differential equations. So we will see the previous questions. See here. The number of bacteria in a culture doubled in 2 hours. When it will be tripled? This is maximum times repeated question. Okay. So what is the question? The number of bacteria in a culture doubled in 2 hours. So first consider the amount of the substance. So what is the solution? First let n be the amount of the given substance. Amount of the given substance. Yes, and observe clearly here, identify here also, this is law of natural growth or decay. So what is the question? When it will be tripled. Okay, so the number of bacteria in a cultural growth doubled in 2 hours. Doubled in 2 hours, when it will be tripled. So here apply the law of natural growth. So what is the differential equation? By law of natural growth, what is the differential equation? dn by dt is equal to, so that is equal to kn. So this is the required differential equation for growth. And simplify, solve this differential equation, that is here also separate the variables. Dn by n is equal to k into dt, and if you apply the integration of 1 by n into dn is equal to k into integration of dt plus c. And what is integration of 1 by n? That is equal to log n is equal to k into t plus c. In equation 1, here also we have two unknown values, c and k. So find out these two values, c and k. So first, how to write the given conditions? Yes, what is the question? The number of bacteria in a culture doubled in 2 hours. So that means initial amount. What is the initial amount? So let when t is equal to 0, when t is equal to 0, assuming that the initial amount is n is equal to n naught. So here you can take any notation, that is your choice. N is equal to n naught. Next, what is the next one? It is doubled in 2 hours. That means when t is equal to 2 hours, amount will be doubled. So that is n is equal to 2 into n naught. Next, what we have to find? When it will be tripled. So that means here we have to find the time. So time when n is equal to 3 into n naught. So using these conditions, find constants, unknown constant values c and k. So first one is when. If you apply the first condition, when t is equal to 0, n equal to n naught. Okay, equation 1 becomes, how to write equation 1? Equation 1 is log n is equal to S. What is the T value is? 0. 0 plus C. So 0 plus C. And N is equal to, initial amount is N naught. So log of N naught is equal to 0 plus C. So from this equation, what is the C value? C is equal to log N naught. What is our next step? Substitute C value in this equation. So substitute C is equal to log N naught. C is equal to log N naught in equation 1. Now how to write equation 1? Equation 1 can be written as log N is equal to KT plus, what is the C? C is equal to log of N naught. So procedure is similar to the Newton's law of cooling. So that is log N naught. Again, from these two equations, how to write? We know that same procedure. So that is, which is equal to log of N by N naught is equal to K into T. So log of N by N naught is equal to KT. So next we have to find K value using the second conditions. So what are the second conditions? When T is equal to 2 hours, no need to convert into minutes. Okay, when T is equal to 2 hours, N is equal to 2 N naught. When T is equal to 2 hours, N is equal to 2 N naught. So consider this new equation as equation number 2. So now how to write equation 2? Equation 2 can be written as log of N equal to 2 N naught. So 2 N naught by N naught is equal to T is equal to 2. So that is equal to 2K. Now here N naught get cancelled. From this equation, what is the K value? K is equal to 1 by 2 into log 2. After finding the K value, again substitute K is equal to 1 by 2 into log 2 in equation 2. So what is equation 2? So that is log of N by N naught is equal to, what is the K value? 1 by 2 into log 2 into T. What we have to find? Time. When N is equal to 3 N naught. So if we consider is equation number 3, so find when N is equal to 3 into N naught. We have to find the T value. So to find the T value, substitute N equal to 3 N naught in equation 3. So now equation 3 becomes log of N is equal to 3 N naught by N naught is equal to 1 by 2 into log 2 into T. Now here if we cancel N naught, so what is the LHS? LHS is log of 3. So log 3, 3 by 1 is 3 is equal to 1 by 2 into log 2 into T. Now write that equation for time T. So that implies from this equation, what is the T? T is equal to 2 into log 3 by log 2. So approximately this value is equal to 3.169. So that is approximately 3. So approximately 3 hours, not minutes. Given time is given time in hours. So therefore, when T is equal to 3 hours, after 3 hours, the initial amount will be tripled. So this is the solution for first question. Next, what is the next question? This is maximum times repeated question. If 30% of a radioactive substance disappears in 10 days. Now here time is given in days. How long will it take for 90% of it to disappear? So here also initial amount is not given. So first let n be the substance of the given amount. So here, what is the identify it? Is law of natural growth or decay? So what is the question? If 30% of radioactive substance disappear in 10 days, how long will it take for 90%? So here apply the law of natural decay. So what is the differential equation? Differential equation is dn by dt is equal to minus kn. This minus k is indicates for decay, and so here n is the amount of the given substance. But what is the initial amount? So we don't know what is. First solve this equation. So how to write this equation as log n is equal to minus k into t plus c. Consider is equation 1. Next, how to write the given data in a proper order. So let n naught be the initial amount. That means n naught be the initial amount. Initial amount of the substance. So that means when T is equal to 0, N is equal to N naught. And given that 30% of a radioactive substance disappear in 10 days. That means when T is equal to 10 days, N is equal to disappear from the initial amount. So N naught minus 30%. So that means 30 by 100 into N naught. So that is equal to 0.7. That means 70% is there. 0.7 into N naught. That means when T is equal to 10, N is equal to 0.7 into N naught. Next, what we have to find? How long will it take for 90% of it to disappear? Here also we have to calculate T. When N is equal to 0.1 into N naught. 90%. So N naught minus 90 by 100 into N naught is 0.1 into N naught. Now using these three conditions, find the two unknown constant values C and K. So how to find out the C and K values? Yes, what is the initial condition? When T is equal to 0, N equal to N naught. When T is equal to 0, N is equal to N naught. So now equation 1 becomes. So what is equation 1? That is equal to log N naught is equal to 0 plus C. So what is the C value here? C is equal to log N naught. Again, successive substitution. So put C is equal to log N naught in equation 1. Put C is equal to log N naught in equation 1. What is equation 1? Log N is equal to minus KT plus C. What is the C? Log N naught. Again, from these two, simplify it. So that is log of N by N naught is equal to minus K into T is equation number 2 after substituting C. Next, we need to find the K value. How to find out the K value? Using the next conditions. When T is equal to 10, what is the N value? 0.7 into N naught. So when T is equal to 10, N is equal to 0.7 into N naught. So if we substitute these two values in equation 2, now equation 2 becomes log of, what is the N value? 0.7 into N naught by N naught is equal to, T is equal to 10. So that is equal to minus 10K. And from this equation, what is the minus K value? Minus K is equal to 1 by 10 into log of N naught get cancelled. 0 by 7 can be written as 7 by 10. 1 by 10 into log of 7 by 10. So this is the K value. What is our next step? Again substitute minus K value in equation 2. Substitute minus K is equal to 1 by 10 into log of 7 by 10 in equation 2. So what is the equation 2? Equation 2 becomes, this is equation 2. So equation 2 becomes log of N by N naught is equal to, what is the minus K? Minus K is equal to 1 by 10. 1 by 10 into log of 7 by 10 into T. Next, what we have to find? So, we have to find the t value when n is equal to 0.1 into n naught. So, if we can in this new equation as equation 3, so substitute when n is equal to 0.1 into n naught. Equation 3, how to write equation 3? Equation 3 can be written as log of 0.1 into n naught by n naught is equal to 1 by 10 into log of 7 by 10 into t. Now, cancel n naught and how to write log of 0.1? That is equal to log of 1 by 10 is equal to 1 by 10 into log of 7 by 10 into t. Rewrite this equation. So, that is equal to log of 1 by 10 can be written as minus log of 10, and here also please take the reciprocal. So, how to write? That is equal to log 10 is equal to 1 by 10 into log of 10 by 7 into t. Now, simplify this equation for t. So, how to write that equation for t? So, t is equal to 10 into log 10 by, yes, so 10 into log 10, and how to write log of a by b? So, that is equal to log 10 minus log 7. Okay. So, this equation is t is equal to log 10 is 1. So, 10 by 1 minus log 7 is 0.845. So, if we simplify this equation for t, so t is equal to 64.5 days. So, after 64.5 days, so the amount of the given substance disappear 90%. So, this is the required time. Here, please mention the units also, days. Okay. Next, orthogonal trajectory. So, orthogonal trajectory of a given curve, we have only Cartesian form. First of all, what is the trajectory? Definition of trajectory. So, simple definition, what is the trajectory? A curve which cuts every member of a given family of curves. A curve which cuts every member of a given family of curves. Suppose if we take, these are the curves. Okay. So, a curve which cuts every member of a given family of curves with a fixed rule. So, then this curve is called the trajectory. Okay. If we take more number of curves, so if we take two family of curves, suppose phi of x comma y comma c is equal to 0 is one family, and f of x comma y comma c is equal to, here c1 c2 is equal to 0 is another family of curves. Okay. If in a family of curves, every member of one family of curves which cuts every member of another family of curves, that is called the trajectories. That is called trajectories. So, that is the definition of trajectory. So, a curve which cuts every member of a given family of curves according to a fixed rule is called an orthogonal trajectories of the family of curves. Okay. What is the orthogonal trajectory? If every member of a given family of curves cuts another family of curves at right angle, here right angle is important, at right angle, then that curve is called, that family of curves is called the orthogonal trajectories of a given family of curves. A family of curves whose members cuts every member of another family of curves at right angle is called an orthogonal trajectories of second family of curves. So, this is the definition, and how to find out the orthogonal trajectories of a given family of curves. What is the working rule? Suppose f of x comma y comma c is equal to 0 is the equation of the given family of curves in Cartesian form. So how to find out the orthogonal trajectory? So first, before going to find the orthogonal trajectory, first eliminate C from the given differential equation by differentiating it with respect to x one time. So that means eliminate C from 1 and obtain the differential equation. What is the differential equation form? F of x comma y dash is equal to 0. After eliminating C, the differential equation form is f of x y dash is equal to 0. So this is the differential equation. So is the given family of curves. Is obtain the differential equation of f of x y dash equal to 0 of the given family of curves. Now here we have to find out the orthogonal trajectories. What is the orthogonal? How to find out the orthogonal trajectory family of curves? Replace dy by dx by minus dx by dy. This is the important condition to find the equation of the orthogonal trajectories. Replace dy by dx by minus dx by dy in equation 2. Then the differential equation is a differential equation of family of orthogonal trajectories. But we need equation of family of orthogonal trajectories. So, and after replacing dy by dx by minus dx by dy, the differential equation becomes f of x comma y comma minus dx by dy is equal to 0 is a first order and first degree differential is a first order differential equation, and we know that how to solve this differential equation. So solve the equation 3 to get the equation of the family of orthogonal trajectories. The solution, general solution of this equation 3 gives the family of orthogonal trajectories of a given family of curves. This is the working rule. Yes. Find the orthogonal trajectories of family of y square is equal to ax cube. So what is the given curve? Given curve is y square is equal to ax cube. Let us take is equation 1 where a is the arbitrary constant. What is our first step? Eliminate arbitrary constant. How to eliminate? By differentiate the given equation one time. So if we differentiate equation 1 with respect to x, differentiate 1 with respect to x, so we get what is the differentiation of y square? 2y into dy by dx is equal to a into differentiation of x cube. What is the differentiation of x cube? 3x square. So from this equation write a value. So from this a is equal to 2 by 3 into y by x square into dy by dx. Take this 3x square left side, that is 2y by 3x square into dy by dx. Substitute a value, substitute a in equation 1. So if we substitute a value in equation 1, so therefore equation 1 becomes, that is y square equal to, what is the a? A is equal to 2y by 3x square into dy by dx into, what is the next coefficient? X cube. Okay, so simplify this equation, that is y square. So if we cancel one y, so y is equal to 2 by 3 into, so that is equal to 2 by 3 into x into dy by dx. But to find the equation of the family of orthogonal trajectories, to find the orthogonal trajectories, so replace dy by dx is equal to minus dx by dy. So if it is equation 2, so replace dy by dx by minus dx by dy in equation 2. So now equation 2 becomes, so that implies y is equal to 2x by 3 into, so what is the dy by dx? Dy by dx is equal to minus dx by dy. Now here the variables are in separable form. Separate the variables, so that is 3y into dy plus 2x into dx is equal to 0. We need equation, so that's why taking integration on both sides. So if we take the integration on both sides, 3 into integration of y dy plus 2 into integration of x dx is equal to c. And what is integration of y? Y square by 2 plus 2 into integration of x is x square by 2 is equal to c. If we cancel these two, so that implies 3 by 2 into y square plus x square equal to c, which is the required equation of family of orthogonal trajectories. So this is the solution. This is the last topic in first unit. I hope you all understood the concepts of first order and first degree differential equations. In the next session, I will start second unit, higher order linear differential equation. Thank you everyone.